Back in 1997, the F-22 Raptor took to the skies for the very first time, a fighter so advanced it practically rewrote the rulebook of air combat. Decades later, in 2023, it finally faced something resembling an air-to-air engagement, taking down a Chinese spy balloon off the coast of South Carolina. Sure, it was an easy target, but here's the kicker. Despite its unmatched capabilities, the US government has never allowed this marvel to fly under another nation's flag, not even allies. Not even close allies like the UK or Australia get a chance to fly the F-22 thanks to the infamous 1998 Obey Amendment. That's how serious the US is about keeping this fighter irreplaceable. With its vector thrust nozzles, it can pull off maneuvers most jets can only dream of. Its stealth tech? On par with the legendary F-117 Nighthawk. But here's the real question. How much does that vector thrust actually help it stay invisible? And why is the Raptor still banned overseas? Meanwhile, the F-35, despite being newer in some ways, is sold to other countries. But the F-22 remains the undisputed king of the skies. Ironically, it's no longer in production. Don't worry, we'll break it down. 4 key traits make the Raptor a predator like no other: speed and agility, stealth, and cutting-edge electronics. The moment it lifts off, it's obvious this isn't your ordinary jet. The F-22's maneuvers look almost like watching an elite athlete with rockets on their feet. Yet its secret isn't just raw speed. The Raptor breaks the sound barrier, but it also mastered supercruise, sustaining over Mach 1.5 without afterburners. Why is that crucial? Before the F-22, most fighters could only go supersonic with afterburners, creating bright flares and radar reflections. A fatal flaw for a jet that relies on stealth, like a magical shield. How does it maintain such speed without giving itself away? That's where its twin massive Pratt & Whitney F-119 engines come in, each generating around 35,270 pounds of thrust. A derivative powers the F-35, producing up to 43,000 pounds. The Raptor also uses vector thrust nozzles, allowing near supernatural agility. Necessity is the mother of invention, and vector thrust proves it. Originally developed to tackle the challenge of vertical takeoff and landing, famously used by the British Harrier, it redirected engine thrust downward to lift off without a runway roll. But the Harrier wasn't designed to improve maneuverability in flight. It wasn't until the 1,990 seconds that a joint US-German prototype, the X-31, pushed vector thrust to new heights. This experimental jet performed maneuvers impossible or deadly for other aircraft of its era, thanks to advanced computers constantly adjusting flight trajectory in real time. With over 500 test flights, the X-31 demonstrated the full potential of vector thrust, laying the groundwork for the Raptor's unmatched agility. A modified F, divided by A-18 Hornet, equipped with vector thrust nozzles and special forward canards, served as the testbed for creating the ultimate fighter, the F-22 Raptor. Often called the king of the skies, this jet can execute maneuvers as stunning as the famous Cobra or J-turn. These moves allow it to evade missiles launched from air defense systems or even enemy fighters. Of course, in real combat, F-22 pilots rarely face such extreme situations, simply because the Raptor's stealth makes it nearly invisible. So invisible, most threats don't even realize it's there. When we talk about F-22 stealth, it's important to remember that Lockheed didn't start from scratch. In the 1,980 seconds, the company had already tested stealth concepts on the F-117 Nighthawk. Back then, the approach relied on sharply angled panels to scatter radar waves, creating misleading signatures for ground operators. Today, stealth technology is far more sophisticated. It's a combination of tools designed to reduce detectability at long ranges, including lowering radar cross-section, controlling noise, thermal signature, and other signals visible to enemy sensors. By the late 1980s, U.S. defense contractors developed radar-absorbing materials, enabling aircraft with smoother, curved surfaces, like the B-2 bomber and later the F-22, improving both stealth and aerodynamics. The number one priority in designing a stealth fighter is preventing radar energy from bouncing straight back to its source. That's why the F-22 has virtually number 90-degree angles on its surfaces, which would act like mirrors, reflecting radar signals. A curious detail: the symmetrical shape of its exhaust nozzles also disperses heat, reducing infrared signature. On rare occasions, you might see an F-22 flying with missiles or bombs under its wings, but these would compromise stealth and the aircraft's sleek profile. Instead, weapons are stored in internal bays, opening just long enough to release their payload before sealing shut, much like the B-2. Even the cockpit posed a stealth challenge. Without treatment, radar waves could penetrate the canopy, bounce off instruments and controls, and return as a clear signal. Lockheed solved this by applying a thin layer of indium tin oxide, giving the canopy its characteristic golden tint. To the pilot, visibility remains almost unchanged, but to radar, it becomes virtually impenetrable. The curved shape of the canopy further deflects electromagnetic energy, so radar illumination rarely produces a coherent return. The Golden Dome is not the Raptor's only stealth trick. The aircraft also features low observable coatings in key fuselage areas, designed to absorb and scatter radar waves. Every time an F-22 lands, it undergoes a meticulous 45-minute inspection, checking the integrity of these stealth surfaces. Whenever the Raptor's stealth coating suffers damage, repairs involve carefully polishing and resealing panels with special compounds to maintain its invisibility. Unlike the B-2 Spirit, the F-22 doesn't need climate-controlled hangars, yet about half of its maintenance hours are devoted to these stealth patches. You might wonder about moving control surfaces like ailerons and flaps, which constantly shift and could reflect radar signals. This is where vector thrust comes back into play. By redirecting propulsion, the Raptor reduces the need for harsh control inputs, limiting the exposure of moving surfaces to enemy sensors. With all these measures combined, the F-22's radar signature can be as tiny as a small metal marble. From a frontal view, you'd swear almost no aircraft is there. Its silhouette is nearly invisible, thanks to ingenious design and angled surfaces. But the most impressive advantage isn't agility or stealth, it's the complex avionics. Only the younger F-35, technologically more recent, even comes close. The key lies in integrated radar and targeting software, providing what's called a first-shot opportunity. In plain terms, the Raptor can detect and eliminate a target before the enemy even realizes it's there. Add near-perfect stealth to that, and the result is a hunter that is almost ghost-like in the sky. The F-22's ghost-like presence is partly because it rarely needs to unleash its famous super maneuverability to evade attacks. Ironically, most of its extreme turns are showcased in air shows rather than real combat. But with all that in mind, a bigger question arises. Why pour so many resources into this advanced fighter when, since the 1992, the US has been fighting asymmetric wars without a true aerial rival? To answer, we need to rewind to the 1980s, when the Soviet Union began strengthening its air power with aircraft like the Beriev A-50, a command and control plane, and legendary fighters such as the MiG-29 and Su-27, both considered highly maneuverable. Before that, US F-15 and F-16 handled the job, dodging radar and missiles with flares and sharp turns. Once it became clear that Soviet technology could match the challenge, Washington moved to design a superior hunter. In the early 1990s, aerospace giants Northrop Grumman and Lockheed competed to create the next air superiority fighter for the U.S. Air Force. Northrop presented the large IF-23, which lacked horizontal stabilizers and featured a diamond-shaped fuselage, reportedly producing two prototypes known as Black Widow II and Grey Ghost. Lockheed, meanwhile, applied all its stealth lessons and technological insights to propose a rival design. Drawing from the stealth program of the F-117, Lockheed proposed the YF-22, now known as the F-22 Raptor. Unlike its rival's diamond-shaped design, the F-22 adopted trapezoidal wings and sturdy, movable horizontal stabilizers. In practice, each prototype had its strengths. The IF-23 offered higher speed and better stealth profile, while the YF-22 excelled in agility and could carry more internal weapons crucial for maintaining stealth in combat. So, what tipped the scales in Lockheed's favor? In April 1991, Northrop was already struggling with cost overruns on the B-2 bomber project and wanted to avoid another astronomical contract. Ironically, the F-22 itself eventually became one of the most expensive fighters ever built. Some analysts estimate each unit cost over $140 million in total development and production. The real surprise came just 8 months after the F-22 was announced as the next great predator of the skies. The Soviet Union, America's main military rival for decades, collapsed. Suddenly, the Air Force faced the paradox of funding 750 cutting-edge fighters without a clear opponent. As development and testing continued, the F-22 made its first flight in 1997. With rising budget pressures, the planned order gradually decreased. By 2005, when the F-22 officially entered service, only 195 units had been ordered, just over a quarter of the ambitious original plan. By the time the F-22 production line closed in 2011, the figures were staggering. Roughly $67.3 billion had been invested, including $32.4 billion in research and testing, and $34.9 billion in aircraft acquisition and military infrastructure. To put it in perspective, by 2009, building an additional Raptor was estimated to cost around $138 million, an eye-watering price, even for Pentagon budgets. The US, Pentagon, and Navy eventually pulled back from any potential naval variants of the F-22. The reason was simple. Operational costs skyrocketed to nearly $7,000 per flight hour, compared to roughly $4,400 for an F-35 Lightning II. Then, in October 2018, between 8 and 12 Raptors were damaged at Tyndall Air Force Base in Florida during Hurricane Michael. Although repaired, the incident highlighted just how delicate it is to maintain the limited F-22 fleet. As if that weren't enough, the US government banned any possibility of exporting the aircraft, even to close allies, to protect its technological secrets. Ironically, not long after, the Joint Strike Fighter program was announced, eventually becoming the F-35, a plane designed to be more affordable, less agile and stealthy than the F-22, yet versatile and exportable. This has allowed it to fly under the flags of multiple countries, from the United Kingdom to Japan. Meanwhile, the future of U.S. air dominance points toward the Next Generation Air Dominance Program, a sixth-generation fighter expected to integrate support drones and cutting-edge avionics, slated for service around 2030. And while a new king appears to be on the horizon, many still believe the F-22 will continue reigning supreme in stealth, speed, and maneuverability, even as the next-generation wings slice through the skies. Beyond raw performance, the F-22 Raptor embodies a psychological edge that few aircraft in history have ever achieved. Pilots speak of an almost visceral connection with the jet, where every maneuver feels like an extension of their own body, a dance between human instinct and technological perfection. This is not just a machine, it is an instrument of dominance, engineered to inspire awe and command respect in the skies. Every stealth contour, every vector thrust adjustment, every meticulously polished surface contributes not only to its physical capabilities, but to a strategic intimidation that rivals simply cannot match. Imagine an enemy radar operator scanning the horizon. unaware that the ultimate predator is already overhead. That split second of uncertainty, that invisible threat, is where the F-22 asserts its dominance without firing a single missile. This psychological leverage is as crucial as its tangible firepower, subtly influencing decisions, dictating battlefield movements, and shaping the perceptions of opponents long before any engagement begins. In the broader context of U.S. air supremacy, the F-22 represents more than a fighter. It is a statement of national resolve. Each flight, each test, each display is a message. The United States will not be challenged lightly. Its presence alone reshapes strategic calculations, forcing adversaries to account for its unique combination of speed, stealth, and sensor fusion. For American audiences, this underscores the sheer ingenuity and determination behind the military-industrial triumph, a tangible reminder that decades of innovation, risk-taking, and relentless engineering have yielded a jet unlike any other in human history. Furthermore, the Raptor's legacy extends beyond the cockpit. Engineers, analysts, and tacticians study its systems not merely to replicate its mechanics, but to internalize the philosophy of dominance it embodies. In classrooms, simulations, and war games, the lessons of the F-22 inform the next generation of fighters, commanders, and defense strategists. It is a living blueprint for technological supremacy, a benchmark against which all future aerial combat platforms are measured. For viewers in the United States, the narrative becomes personal. The F-22 is a symbol of national pride, of cutting-edge American innovation, and of the relentless pursuit of excellence. It evokes emotions of awe, respect, and even a touch of fear, capturing imaginations and reinforcing the idea that air superiority is both a science and an art. Its story is one of vision, perseverance, and the extraordinary lengths humanity will go to achieve mastery over the skies.